I wanted to give some more examples on finding possible rational zeros with the rational root test. So here are 4 more problems on finding the rational zeros. So let's look at the leading coefficient and the final coefficient. The idea is we look at the factors of 18. So the factors of 18 are 1, 2, 3, 4 doesn't work, 5 doesn't work, 6, 9, and 18. And you can think about it this is 1 and 18, 2 and 9, 3 and 6. So you see we've got everything. For 3, we have 1 and 3. So the rational root theorem says we take one of these, divide by one of these, and say plus or minus. So if we divide by 1, we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Now let's divide each of these by 3. If I take 1 and divide it by 3, I get plus or minus 1/3. If I take 2 and divide it by 3, plus or minus 2/3. I'm not going to write down 3 divided by 3 because that's already listed. It's 1. 6 divided by 3 is already listed. That's 2. 9 divided by 3 is already listed. That's 3. And 18 divided by 3, that's already listed. That's 6. So these are our possible rational roots. Now, because of the degree of the polynomial, we know that it can only have up to 4. But 1, 2, 3, 4, 5, 6, 7, 8 times 2, there are 16 possible rational zeros. Let's try this again. We list out the factors of the constant term. 16, 8, 4, and 1. I believe that's it. Oh no, 2. So we have to list all of the factors. Those are all the factors of 16. And again, the factors of 3 are 1 and 3. So we'd say plus or minus 16, plus or minus 8, plus or minus 4, plus or minus 2, plus or minus 1. That's dividing by 1. Now let's divide by 3. Plus minus 16/3. So I'm going to divide each of them by 3, and in this case, none of them are already repeats of what was already listed. So I'm just going to say all of these are possible rational roots. So this is 5, 10, and then plus or minus versions of each of these, so that would be 20 possible roots. The factors of 125 are 1, 5, 5 times 25 is 125, and 125, and that's about it. Now, there's nothing listed here, so the factor is 1 for the leading coefficient. So we can just say it's plus or minus each of these. Plus or minus 1, plus or minus 5, plus or minus 25. I'm dividing each of these by 1, but dividing by 1 doesn't make a difference. So that is 8 different roots. I should say 8 possible roots. Not that any of these are actually true, but those are the possible ones. Last example, we look at the factors of 27. 27, 9, 3, and 1, 6, 3, 2, and 1. So we're going to take the factors of the constant. If we divide by 1, we get these. What if we divide by 2? Well, each of those will be a new thing. So I've checked off 1, I've divided by 2. If I divide this by 3, it's already listed. If I divide 9 by 3, it's already listed. If I divide 3 by 3, it's already listed. If I divide 1 by 3, that's plus or minus 1/3. So we have to do that as well. And lastly, we have to divide by 6. If we divide 27 by 6, we'll get 27/6, which simplifies to 9/2. Same thing, 9 divided by a sixth, or divided by 6, is 3/2. 3 divided by 6, 3 divided by 6 is 1/2, so plus or minus 1/2 is another option, and 1 divided by 6. So these are our possibilities. These I got from dividing by 1. These I got from dividing by 3. These are, sorry, divided by 2. These are what I got by dividing by 3. These are what I got divided by 6. Notice that I listed that twice, so I need to cross that out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 2 is 20 possible ration roots.